Okay, in this section, we're going to go over 6.1, Part 2. We're going to introduce the concept of radian measurement. So this is brand new, so you really have to give this your complete and utter focus, both in class and when doing the homework. Okay, so in section, and this should be, this should say section 6.1, Part 1, we defined an angle as the joining of two rays at a vertex. We are now following to extend this concept by superimposing a circle on top of the XY axis and then doing the following to create an angle. So this is what we're doing. So remember, we had this angle, okay? We're just putting it inside a circle. So running an initial segment along the x-axis, so that means it's in standard form. Okay, we're going to put it here, and we're going to open up this way in a positive direction. Okay, so we're starting there, and we're going to move up along this circle. Okay, traveling from the end of the initial segment along the circle in a pattern called a circular arc. Okay, and stopping at a point of our choosing as highlighted in green. So let me change that to green so I didn't unhighlight the highlighting. Okay, so here is what we've done. Okay, connecting a segment from the origin to the stopping point that we choose in step 2 is shown in blue below. So let's see what we're doing here. So here is your blue. Here's where you're going to, here's where you're going to end. The red was where we started. And here's the direction, the positive direction that we moved in. Okay, so that's our angle. The only difference from the previous day is that now it's inside a circle, and that's going to be important to our understanding of radian measurement. Okay, so these 3 steps, the most important being where we travel along the circular arc. Okay, so this is the piece right here that's new. We hadn't talked about this. That's your circular arc. And we created angle theta. There are a few things that we will note from the work above. The length of each segment, so this is a segment, is equal to the radius of a circle, right? From the center out to that circle is the radius. From the center out to the circle is the radius. The length of the circular arc is designated as S. Here's a new name. This angle theta is a central angle. It's right at the origin. So that's a central angle. Now we can say this fancy term. Angle A is said to have been subtended by our circular arc. You can replace that word in your head with the word created. Okay? The angle was created once we moved along the arc. Okay, these elements now lead into a new way to measure the size of an angle theta in terms of radians. Simply define, radians measure the ratio between the arc length, that's the S, and the radius value R. So the angle that we've subtended or created equals the S over the R. We can therefore conclude that an angle of 1 radian occurs if S and R are the same. Okay? So remember, your units are radians, sometimes abbreviated rad. Okay? If the central angle theta is subtended, created, by an arc that's equal to its length to the radius, then theta equals 1 radian. Why is that? So let's just say that S equaled just 10, and the radius equaled 10, and the units are radians. Doesn't that equal 1 radian when they're equal? That's all we're saying. Okay, so don't get confused by that wording. Okay, when your arc makes 1 complete revolution, the arc length is equal to 2 pi r. And that's the circumference of a circle. So when S equals 2 pi r, then theta equals 2 pi r over r, or 2 pi. So that means in a circle, you have 2 pi radians. Okay? So an arc that makes a full revolution around a circle creates an angle of 2 pi. Okay, so let's think about this. If you make a full revolution, that's 2 pi. If you make a half revolution, it's half of 2 pi, which is just pi. If you make a fourth of a revolution, so it would just be only here, it would be 1/4 of 2 pi. Okay, can you think along those terms? I'm going to write it as fractions to see if we can reduce this. So let's go back. 1/2 of a full revolution. The 2's cancel, that equals pi. 1/4 of a full revolution. What does that equal? 2 goes into itself 1 time. 2 goes into 4 2 times. That equals pi over 2 radians. 1/6. So 1/6 times 2 pi. 2 goes into itself 1 time. 2 goes into 6 3 times. That's going to be pi over 3 radians. Okay, so I'm just doing multiplication. So don't, freak out about that. In terms of how we're going to label this, a half of a revolution is going to be pi. A fourth is going to be pi over 2. And a third will be pi over 3. Okay, we're going to play around with this. We will often switch between degree and radian measures. With a little bit of work using the table below, we can convert back and forth pretty easily. Okay, what do we know? How many degrees is in a full circle? That would be 360, because 2 pi equals a full circle, which equals 360 degrees. Pi is half of a circle, so that's 180. Pi over 2 is half of a circle, so that's 90. Pi over 3, what do I do with that? Well, look at this. Take your pi, divide by 3. Aren't we going to get 60 that way? Take your pi, right above, and divide by 4. That gives me 45. And these are all degrees, so I have to be writing those clearly. Take your pi and divide by 6, and that gives me 30 degrees. So clearly, I'm using that 180 equals pi for my conversion factors. Okay? If you want radians, if you want degrees, so if you want degrees back, have degrees in the numerator. If you want radians, have pi in the numerator. So if I'm going to convert 50 degrees to radians, I have degrees. I'm going to multiply by pi over 180. Okay, so divide both by 10, and you get 5 pi over 18. Convert negative pi over 9 to degrees. I want degrees. I put degrees up top. Look what's going to happen. The pi's will cancel, the negative stays, and 9 goes into 180 20 times, so that equals negative 20. I want radians, therefore I put my degrees in the denominator. Divide by 10. It looks like 2 can go into 16 8 times. It can go into 18 9 times. So that's going to be 8 pi over 9. 5 pi over 6, I want degrees. Put the 180 on top, put your degrees on top. Cancel the pi's. 6 can go into 180 30 times. 5 times 30 is 150 degrees. So go back, review that, make sure that makes sense to you. So to convert degrees to radians, if I want radians, have the radians on top. To convert radian measurement to degrees, if I want degrees, have the degree on top. What does pi radians over 180 equal? Well, that just equals 1. That's why I can just multiply by it and not change the value. I'm just converting the units. Okay? So that's a conversion factor. So we can think about that as a conversion factor. Okay, let's keep going. Okay, so we're going to do some more practicing here. So for each of these, we're going to convert. If I want degrees, I multiply by 180 degrees over pi, and I reduce, and I should get 135 degrees. If I want radians, I'm going to multiply by pi over 180, and when I do that, I'm going to get 10 pi over 9 degrees. Okay, check this for yourself. If I want degrees, I want my degrees to be up top. When I do that, I'm going to get 420 degrees. If I want radians, I have my pi on top. And when I do that, I'm going to end up with 21 pi over 18. And then just looking at that, I can convert that to 7 pi over 6. If I want degrees, I put my degrees on top. The pi's cancel. I end up with 390 degrees. Continuing on, if I want radians, I'm going to put a negative here so I don't forget. I'm going to multiply by pi over 180 and reduce, and I'll end up with negative 17 pi over 9. If I want degrees, I'm going to multiply by 180 over pi, and that's going to give me negative 90 degrees. If I want radians, put my pi on top. That's going to end up giving me what? Negative 25 pi over 9. I want degrees, so I put the degree on top, and that's going to give me 3600 degrees. Okay, if I have 3600 and I multiply by, I want to get radians, so pi over 180, you should have guessed that I'm going to get 20 pi back. Okay? All right, coterminal angles, same idea. Remember, we did plus and minus 360? Well, guess what we're going to do this time? Plus and minus 2 pi. Because 2 pi and 360 are the same. If we want it in radians, we've got to use plus and minus 2 pi. So find two angles, one positive and one negative, that are coterminal with pi over 4. So I'm going to say, okay, pi over 4 plus 2 pi. Okay, now I can't add 2 pi to pi over 4 unless I multiply 2 pi by 4 over 4. That's going to give me pi over 4 plus 8 pi over 4. Add them together, I get 9 pi over 4. Okay? If I want to get the negative coterminal, I'm going to take my original, pi over 4, and subtract my 8 pi over 4, and that gives me negative 7 pi over 4. Okay, find two angles, one positive and one negative, that are coterminal with negative 2 pi over 3. So I have negative 2 pi over 3. I'm going to add 2 pi, but I can't do that unless I multiply by 3 over 3. So that means I'm taking negative 2 pi over 3 plus 6 pi over 3, and that gives me a 4 pi over 3, which is positive, so that's good. Then to get the negative one, I'm going to say negative 2 pi over 3. I'm going to subtract 6 pi over 3. That gives me negative 8 pi over 3. Oh, excuse me, honey. What am I doing here? Hold on 1 second. Let me just look at that. Okay, oh yeah. Okay, I'm good. So I have 4 pi and negative 8 pi. I'm good. Okay, so this is what I have for my answers. I have positive 9 pi over 4, negative 7 pi over 4, positive 4 pi over 3, and negative 8 pi over 3. So this was a key thing. So I'm going to say, definitely know how I'm doing this, because you've got to be able to add fractions. In order to add fractions, you need to have the same denominator. Okay, so here's some more practice. I need coterminal angles. So I want positive. This is the positive. This is the negative. So let's come over here. And I know I have to add and subtract 2 pi. But I'm going to look at this and say, if I'm in thirds, I'm going to add and subtract 6 pi over 3. If I'm in fourths, I'm going to add and subtract, 8 pi over 4. If I'm in sixths, I'm going to add and subtract 12 pi over 6. Do you see how all of these reduce to 2 pi? So now let's do that. If I add 6 pi over 3 to pi over 3, I get 7 pi over 3 for my positive coterminal angle. If I subtract 6 pi over 3, I get negative 5 pi over 3 for my negative coterminal angle. If I add 8 pi over 4 to 5 pi over 4, I get 13 pi over 4. If I subtract 5 pi over 4, I get negative 3 pi over 4. Okay, 11 pi over 6. If I add 12 pi over 6, I'm going to get 23 pi over 6. If I subtract 12 pi over 6, I'm going to get negative pi over 6. Okay, let's continue and do that the same way. So if I know I have to add and subtract 2 pi, and I'm dealing in seconds, then I'm going to say I need 4 pi over 2. If I'm dealing in sixths, I already know I'm going to do 12 pi over 6. And if I'm dealing in thirds, what do you think I should do? How does 3 over 3, so that's 6 pi over 3. Again, if you look at what I just wrote in red, you can see that everything will reduce to 2 pi. Okay, let's find the positive coterminal and the negative coterminal. If I add 4 pi over 2 and 3 pi over 2, I get 7 pi over 2. If I subtract away 4 pi over 2, I get negative pi over 2. Okay, if I add 7 pi over 6 and 12 pi over 6, I get 5 pi over 6, which is my positive coterminal angle. If I subtract away 12 pi over 6, I will get negative 19 pi over 6. Okay, if I add 6 pi over 3 to negative 5 pi over 3, I'll get a positive pi over 3. If I subtract away the 6 pi over 3, I will get a negative 11 pi over 3. Okay, you've got to be comfortable, super comfortable with dealing with fractions. Okay? All right, let's keep going. Okay, for each of the following angles, determine the angle to which the given angle is coterminal such that we're between here and here. Now, didn't I just do that right here? No, here I had one positive, one negative. Here I just want one angle. And that one angle has to be on my circle. So it has to be between 0 and 2 pi. So let's do the same thing here. Here's my 2 pi. If I'm dealing in seconds, then I need 4 pi over 2. So let's do this first. If I'm dealing in 6, then I need 12 pi over 6. If I'm dealing in thirds, then I need 6 pi over 3. And you can see that each of those red values will reduce to what? 2 pi. Okay, so if I add, so I need a coterminal on the circle. If I add 4 pi over 2, I'll still have a negative. So what I have to do is I have to take my negative 7 pi over 2, and I'm going to add 4 pi over 2 twice. Okay, that gets me pi over 2, and I know I'm okay. Okay, if I subtract 12 pi over 6, I can get pi over 6, so that's a coterminal. Okay, what about the 10 pi over 3? It looks like I need to subtract. That gets me 4 pi over 3. So you've got to look and say, am I on this circle? Okay, this is a very big negative number. Let's first off do that 2 pi conversion. If I'm dealing in fourths, I'm going to do 8 pi over 4. If I'm dealing in whole numbers, I can just do 2 pi, right? Here's another whole number. I can just do 2 pi. Okay, if I add 8 to negative 19, I'm still negative. So I think I'm going to have to take my negative 19 pi over 4 and add this one time. Okay, that makes it 16. That's 2 times. One more time. If I do that, what am I going to have? 8, 16, 24. So that's going to end up with 5 pi over 4, and that number falls between 0 and 2 pi. Okay? Because if you're in fourths, you have to fall between 0 and 8 pi over 4, and I do. Okay, so this one's too big. So if I keep subtracting 2 pi's, I have to do that all the way down to 0 over pi. This one's too big also, so I have to keep subtracting 2 pi until I get on that circle, and I'm going to do that all the way down to 1 pi. Okay, so play around with that, see if you can get that. Okay, so now this is kind of like Captain Obvious, but we have now added the radian measurements to our diagram. So look what we've added. 90 is pi over 2, 0 is 0 radians, and 360 is 2 pi radians. 270 is 3 pi over 2 radians, 180 is pi radians. Okay, so that's what you need to know for your diagram. Okay, so now we have to figure out what quadrant that this angle lies in. So 7 pi over 4. What can we do with that? It's in fourths, so I am thinking, let's see if we can figure out the coterminal angle. So I want to be between 0, let me not do that, between 0 and 2 pi. So in this situation, I want to be between 0 and 8 pi over 4. Okay, so 8 pi over 4 is greater than 7 pi over 4. That means that 7 pi over 4 must fall in quadrant 4. Okay, 5 pi over 6. Look at this fraction. 5/6 of pi. If pi is right here, then 5/6 is a little bit less. So that's in quadrant 2. Okay, This is too big. So, so sorry, too much talking. 8 pi over 3, I'm going to use coterminal angles because I know 8/3 is greater than 2 pi. So it's beyond my circle. So if I want to subtract 2 pi, what will that be in terms of thirds? I could subtract 6 pi over 3, which gives me what? 2 pi over 3 for the angle. Okay, so this is 2/3 of pi. All right, 90 degrees is half of pi. That puts this angle in quadrant 2. Okay, negative 5 pi over 4. Clearly, that's too small of an angle. So I'm going to add to that. I have to change my 2 pi to fourths. So I'm going to multiply it by 4 over 4. So I'm going to add 8 pi over 4. That gives me what? 3 pi over 4. And think about that. Where would 3/4 of pi be? It would be in quadrant 2. So this you may need to really think about because it may not come to you the first time through. Okay, so now we have some other formulas. We're going to try to figure out two things. The arc length, which is the S. So think about that as the pizza crust. Okay, that's my pizza crust. The area is all of this. That's the pizza slice. Okay, so I know it's a strange thing to think of it in terms of food, but it may help you understand this. So the shaded area is called a sector. So the area is called the sector. And the crust is called the length. Okay, so this is the length, and this is the area. Okay? Okay, if we're given the radius of a circle and the measure in radians of the central angle subtended or created by our circular arc, we have the ability to calculate the arc length and the area. Okay, here are your formulas. So these are your formulas. Now, the most important thing about this is your angle has to be in radians. So I'm going to add the caveat. If it is not, then convert it by using what? Oops, sorry, let me write that a little bit better. By using, I want radians, pi over 180. Okay, so let's read this first question. It says, find the arc length and the area of a circular sector created by a central angle of 2 pi over 3. So that's that. If the radius equals 6. Okay, so they want two things. The arc length. So let's get that. We're going to do that one first. S equals R times theta. They gave me R. They gave me theta in radians. That looks like the length is going to be what? 4 pi. Okay, 2 times 2 times pi. Okay, so that's one answer. Now let's do the other. So we want to figure out the area. So we're going to use area equals 1/2 r squared times theta. So 1/2 r squared is 6 times 6, which is 36, times theta, which was 2 pi over 3. So let's start cleaning this up. This 2 can cancel that 2. and 3 can go into 36 12 times. So I'm getting 12 pi. Okay, let's go on to number 12. And 12 says, find the arc length. So what's that? That's your S. That subtends, creates a central angle of 120 degrees in a circle with radius 5. Okay, first thing you have to do, this cannot be in degrees. Take your 120 and multiply it by pi over 180. And then reduce it nicely. 6 goes into this 2 times, 6 goes into this 3 times. 2 pi over 3 equals my theta. Now I'm set to go. All they want is, well, first they want the arc length. Well, I guess all they want is the arc length, right? So all they want, find the arc length. Okay, so that's S. I know that S equals R times theta. So here's my R. Here's my appropriate theta that's in radians. 10 pi over 3. And should that do it? Let's see. What did I do? Yep. So 10 pi over 3 does it. And that is my arc. That's my my length of the pizza crust, okay? My arc length. So I'm all set with that. Okay, so then 13. Here I give you the formula again. We're going to give you these formulas. The area of a circular sector within a circle has a radius of 3. So I'm going to write down what I have. Radius of 3 centimeters. And so the area is 24 centimeters squared. Determine the size of the central angle along with the arc length. So I need the angle and I need the arc length. So what am I going to do? Well, I'm thinking I should work with the area. So if my area equals 1/2 r squared times theta, what do I have? I have this is 24 equals 1/2 r squared is 9 times theta. So that is 9 over 2 theta. So 24 equals 9 over 2 theta. 1 and I multiply both sides by 2/9, right? So multiply that by 2/9. That cancels. I want to get theta by itself. Do the same thing over here. And it ends up that theta equals, okay, 2 times 24 is 48 over 9. Okay, so that's my theta. Now, if I have my theta, what else do I now know? I have this. Can't I also figure out the arc length? Sure, because the arc length, I'll change color just for a contrast. That equals, so far I know that this is 48 over 9. Okay, and that has to be in radians, and I'm okay because that's all good. Okay, so now S equals R times theta. I know that R was given to me as 3, and this is 48 over 9. So the arc length, 3 can go into 49 3 times. So 48 over 3. And 3 goes into 4 1 time with 1 left over. So that looks like 3 goes into 18 6 times. So this is going to equal 16 for my arc length. Okay, so those are the last 2 problems. Here is this for my arc length, and here is this for my theta. So just filling it in over here. This is 16. And these are my answers that they asked me for. Okay, so here's the homework. So I broke it down so you can see what it is you're working on. So you're going to do a little reading. The textbook goes right into radians. They don't separate out degrees first. So you're going to do some conversion. You're going to do positive and negative coterminal. And you're going to work with the two formulas. So that's the homework. Okay, so work on that. Do this really well, and you will be in good shape with this material.